Hello, warm welcome to everyone in our event related to the hazardous medical waste and its management. I am Raghavendra Shah, medical lab scientist at the medical lab technologist in context of Nepal, and I am an admin of next generation lab technologist of Nepal. Today I am going to present uh, the hazardous medical waste, its categories, healthcare waste and its management. Let's initiate our topic. I have included the introduction portion of the hazardous medical waste, objectives, why we should do its management, why should we segregate it, why we should categorize it, existing national acts, rules and regulations related to the healthcare waste management, categorization of the hazardous medical waste, hazards caused by the health waste and the hazardous medical waste, organizations or the committee formed in the healthcare facilities to manage the hazardous medical waste, and at last waste management, how we will do it, what are the different hazardous medical waste, and what treatment should be done before disposing it or sending it to the landfill site. Let's get deeper into our topic. First of all, introduction portion. Hazardous medical waste are the waste that are generated in the healthcare facilities, uh, pathological lab, radiological department, pharmaceuticals companies, while performing researches, veterinary hospitals. These all are the wastes that are generated in the healthcare facilities and which is also known as the healthcare waste. But not all of the healthcare waste come into the hazardous medical waste. Only 20% of the healthcare waste come into the hazardous medical waste. According to the WHO 1999, healthcare wastes include all the wastes generated by the healthcare establishment, research facilities and laboratories. According to the Solid Waste Management Act 2011, medical waste means the hazardous waste produced and discharged from hospitals, clinics, pharmacies, dispensaries, blood bank, pathology laboratories, veterinary institutions and health research centers. Similarly, according to the UNEP-SBC and WHO 2004, waste from the healthcare facilities include following categories of wastage: non-risk healthcare wastage that do not cause any infection or degrade the health of the healthcare as well as the community people living near the healthcare facilities, as well as there is the less chance to degrade the environment by such wastage. Healthcare waste requiring special attentions. Such healthcare wastes should be treated before disposing. Infectious and the highly infectious waste. Such waste should be first disinfected and then it should be disposed or sent to the landfill site. Other hazardous wastes and the radioactive wastes such as heavy metals, radioisotopes, radionuclides, etc. Uh, Again, I want to say that among all these wastes, 20% are only hazardous, and which is supported by the WHO 1999, which is less comparatively, but it leads to the higher impact on the environment, community acquired infection, degradation of the quality of natural resources, and health hazard to the living beings. So its proper management is necessary from its organization sector of country for good infection prevention practices. Slide. Objectives. What are the motives for classifying the hazardous medical waste and its management? Protection of the public health by reducing the exposure of employees, patients, attendants, and entire community to hazardous healthcare workers in the work environment. Enhance community relation by demonstrating a commitment to environmental protection. Reduce waste handling and the disposal volume along with the cost without compromising the quality of healthcare. Increase employee resulting from a healthier and the safer working environment. Next content. Existing national act rules and regulation related to the healthcare waste management. There are the different acts and the rules uh, amended in the different year by the organization and the government. So first of all, Solid Waste Management Act 2011. This act was amended to provide legal basis and the regulation for the healthcare wastage, to make arrangement for systematic and the effective management of the solid waste by minimizing solid waste at sources, to maintain clean and healthy environment by minimizing the adverse effect of the solid waste in the public health and environment. Next act, the Town Development Act 1989. This act was promulgated in order to provide necessary services and facilities to the resident of the town by reconstructing, expanding and to develop existing towns, by constructing new towns and to maintain health, convenience and economic interest of general public. Another act is the Local Self-Government Act, which was amended in the 1999, and this act has empowered the local body to fine anyone up to the Rs 15,000 for haphazard dumping of solid waste. And this act was made provisions for managing domestic solid waste. However, the act does not require the local government to manage hazardous waste. These are supported by the municipalities to preserve water bodies such as lakes and rivers and assist in controlling water, air and noise pollution. Similarly, another act was formulated in the 1997, known as the Environment Protection Act and the Environment Protection Rules. And this act was formulated to reduce the adverse impact on the environment likely to be caused from the environmental degradation on human beings and ensure the proper use of natural resources for environmental conservation. Another Solid Waste Management Policy 1996. This policy was formulated relating to the management of solid wastes, and the objective of these policies are to manage to make management work of the solid waste is simply and effective, to minimize environmental pollution caused by the social wastes and adverse effect thereof to the public health, to mobilize the solid waste as resources, to privatize the management work of the solid waste, and to obtain public support by increasing public awareness in the sanitation work. Similarly, the Industrial Enterprises Act 1992, and this act was promulgated to facilitate the employment opportunity by creating an environment of industrial investment. The act states for the establishment of an industry affecting safety, public health and environment, permission from the concerned department is required. Similarly, the Labor Act 1992, and this act was used to regulate the governing the working environment by making provision for right interest, facilities and safety of workers and employees working in enterprises of various sectors. And the last one is the Guidelines for the Health Institution Establishment, Operation and Upgrade Standard 2070. And this guideline deals with the infrastructure and standards required for the operation of health institutions like emergency services, OPD and inpatient services, pharmacy, emergency preparedness, waste disposal and management, and all other prerequisites. Next slide, please. Categorization. In this topic, we will categorize the healthcare waste as well as hazardous medical waste. Actually, healthcare waste embraces all the waste is generated through all the medical activities that include the diagnosis, preventive, curative, and palliative treatment of human beings, research pertaining to the above activities, and production or testing of biologicals. First of all, let's categorize the healthcare wastage. It can be categorized into non-risk healthcare waste and the risk healthcare waste. Uh, Non-risk healthcare waste can be further categorized into the biodegradable and the non-biodegradable. And the biodegradable waste are the waste that can decompose, like leftover food, garden waste, papers, etc. Non-biodegradable waste, actually they do not decompose uh, for the long time, so its large volume can be recycled. It includes the bottles, can, paper, different plastics, and the glasses. Risk healthcare waste, which can be also known as hazardous medical waste. Infectious wastage, sharp wastage, pharmaceutical wastage, cytotoxic waste, radioisotopes, and other hazardous wastage. Let's get into the infectious wastage. Infectious wastage consists of the pathogens, and it contamination poses a risk of disease transmission from one person to another person in the lab, or uh, from one person to another person in the community. It can cause the endemic, epidemic as well. This category includes waste contaminated with the blood and other body fluids, laboratory culture, and the microbiological stocks. And waste includes excreta, other materials that have been in contact with the patient infected with highly infectious diseases. Sharp wastage. Sharps are all objects and the material capable of cutting or penetrating the skins. The wastage poses a potential risk of injury and infection due to their puncture or cutting properties. Example of such wastage includes all type of needles, broken glasswares, ampoules, scalpels, blade, lancet, cover slip, glass slides without content. Pharmaceutical wastage, pharmaceuticals that have passed their recommended shelf life, or pharmaceuticals that are unstable, that are generated in the pharmaceutical companies, pharmacy stores, and the pharmacy shops. Cytotoxic waste. Cytotoxic waste can arise by use or by manufacture and the preparation of pharmaceuticals with cytotoxic effects. Such wastes are managed by return back policy or sanitary landfill with encapsulation. Pathological waste. Pathological waste consists of the human body parts, organ, and the tissues. Example of such wastes are tissue waste, removed organs, amputated body parts, placenta, blood, body fluid, human fetus, animals, and carcasses obtained through medical procedures. And such wastes can be managed uh, by boring deeper into the land side. Chemical wastage. Chemical waste is the waste with chemicals which, if managed or disposed improperly, may pose substantial hazard to the human health. It includes chemicals used in the laboratory, unused photofuels, contaminants, solvents, batteries, broken thermometer, and blood pressure measuring equipments. Such chemical waste needs to be first segregated, or uh, to minimize the quantity of the wastage. If it is hazardous, it should be treated before disposing into the sewage or um, landfill side. Radioactive wastage. Material contaminated with radionuclides which arise from the medical or the research use of radionuclides. It includes unused shield radiation, sources, liquid and the gaseous material contaminated with radionuclide, excreta of patient who underwent radionuclide diagnostic and the therapeutic application, paper cups, straws, needle, syringe, test tubes and the tap water used to wash, paraphernalia. Next slide. Hazards caused by the hazardous medical waste. We can categorize it into direct or the immediate impact on the health, and another indirect or the delayed impact on the health. Uh, on the basis of the type of infection, hazardous medical waste can be categorized into the gastroenteric infections, respiratory infections, ocular infections, genital infections, skin infection, anthrax, meningitis, HIV/AIDS, hemorrhagic fever, bacteremia, viral hepatitis A, viral hepatitis B and C, candidemia or candidiasis. I have included the causative organism as well as the transmission vehicles in these slides. Hope you all have the ideas regard to this, so I am not going to discuss this slide more. Next slide. Indirect risk via the environment. I have included here or categorized indirect risk where the environment, because there are the different wastes or the chemical wastes we do not hamper our health instantly, but it causes longer term health hazards to us because mercury toxicity, phenol toxicity, etc. They can cause later on impact on our health as they get deposited in our organs, tissues. As we discard waste by pitting or discharging in the sewage ultimately into the water, the harmful toxic chemical accumulate in the natural resources and degrade the quality of natural resources. And with the living beings are the byproduct of natural resources, the harmful toxic chemical accumulate in our body organs and the tissues ultimately leads to dysfunctions such as DDT, heavy metals such as mercury, phenols and its derivative, and disinfectant and antiseptics may have toxic effect on the natural ecosystem. Dioxin, furans and coplanar polychlorobiphenyls, which are formed due to inefficient incineration and open burning of healthcare wastes, are persistent organic substances that do not readily break down into the environment and bioaccumulate in the food chain. Substances steps need to be taken to reduce these emissions by waste minimization, environmentally safe alternatives, and in-house management of wastage in the healthcare facilities. Waste segregation refers to the process of separation of waste at the point of generation and keeping them apart during handling, collection, interim storage and transportation. Also, a key principle of successful and safe waste minimization is the most important step for a successful management of the healthcare waste. In fact, it reduces the quantity of that waste which are hazardous and require. Sorry for the disturbance and the pause. We are at the waste segregation, which refers to the process of separation of the waste at the point of generation and keeping them apart during handling, collection, interim storage and transportation. Also, key principle of successful and the safe waste minimization and is the most important step for a successful management of healthcare waste. In fact, it reduces the quantity of that waste which are hazardous and require special attention and treatment. Waste collection and the storage. In order to avoid accumulation of the waste, it must be collected at the small site or at the large site, which is located at the central storage area within the healthcare facilities or at the further distance away from the patient room, laboratories, hospitals, function rooms. Waste need to be collected and transported away in the daily basis. Proper coded storage bins should be used for the waste collection. For the non-risk healthcare wastage, we can use the green bin. For non-risk waste, biodegradable green, non-risk waste recyclable dark blue, other non-risk healthcare waste light blue. For the healthcare waste requiring a special attention or the risk healthcare wastage, such as pathological waste, we can use red bin. And the waste, we can place human body part, organ, human tissues, removed organ, amputated parts, bone marrow. For hazardous sharp, we can again use red bin. And the waste, we can place that needle, glass rings with fixed needle, scalpels, blade, glass, etc., which may cause puncture and the cuts. For the pharmaceutical, again we can use red bin, and we can place unused and the date expired drugs there. Similarly, for cytotoxic pharmaceutical waste, we can again use red bin. And the wastage, we can place our waste with anti-neoplastic effects such as alkylated substances, anti-metabolites, antibiotics, plant alkaloids, hormones, etc. For dangerous hazardous infectious waste, we can use brown bin. And we can discard items contaminated with the blood and the body fluids from clinically confirmed infected patient, including cotton, dressing materials, soiled plaster, linen, bleeding, swab, gloves, syringe without needle, infusion equipment with spike, bandage, and other material contaminated with blood, dialysis equipment, blood from patient infected with HIV, viral hepatitis, brucellosis, respiratory tract infection, secretion from patients infected with TB, anthrax, and the rabies. For the chemical waste, we can use the aloe bin. Uh, for the radioactive waste, we can use black bin. And the wastage that includes the solid, liquid, and gaseous waste contaminated with radionuclides such as cobalt, technetium, iodine, iridium generated from in vitro analysis of body tissue and fluids, in vivo body organ imaging, and tumor localization. Next slide. Waste transportation. Healthcare waste collection and the transportation activities should be designed and planned to ensure safe movement of the waste from the point of generation to the storage and ultimately to the treatment center. Proper plans should be prepared for the collection and the transportation of the waste. It can be categorized into the on-site transportation and off-site transportation. On-site transportation is required in the large healthcare facilities to transport the health from the site of generation, such as lab or the radiology department or the surgical department, to the storage site. And off-site transportation, uh, it is uh, it is transported from the healthcare facilities to the landfill side, and it should be well managed and properly treated. Waste treatment and disposal. The method for the treatment and disposal of healthcare wastes depends on the specific factors applicable to the healthcare facilities, relevant legislation, and environmental aspects affecting the public. The hazardous waste and infectious waste must be managed by approved treatment method. Once treated, the waste may be reclassified accordingly for disposal. Hazardous medical waste can be treated and disposed through the following techniques. Biological procedures. It includes the composting, vermicomposting, and anaerobic digestions, and these all methods of the treatment are nature friendlier, ecology friendlier, and it does not degrade the human health, as well as do not degrade the health of community people, and does not degrade the quality of the natural resources as well. Composting. Composting is the natural biological decomposition of organic matter by fungi, bacteria, insects, worms, and other organisms. Successful composting entails the management of decomposition process so that it is relatively quick, safe, and clean. Vermicomposting. Vermicomposting is the process of degradation of biodegradable material through worm, and the specialized worms can spread up the digestion process through the vigorous digestion of the materials. Anaerobic digestion. During anaerobic digestion, biodegradable waste is degraded in the absence of oxygen. The process occurs due to the anaerobic organism, which result in the production of methane as byproduct. Nowadays, recent studies are made by the anaerobic organism. We can uh, digest the plastic contents as well. Uh, Next slide, please. Steam-based treatments, autoclaving. Autoclaving is the process of steam sterilization under pressure. It is low heat process in which steam is brought into direct contact with the waste material for a sufficient duration to disinfect the material. This technique has been used for a long time in the healthcare facilities for sterilization of reusable medical equipment. Microwave. Microwave treatment is a steam-based treatment technology where microwave energy generates moist heat and the steam by heating the moisture in the waste. Microwave radiation is used for the treatment of infectious healthcare wastage. Frictional health uh, treat, frictional heat treatment. Frictional heat treatment. This technology uses both steam as well as dry heat. High speed rotating shredders generate heat and the moisture in the waste turn into steam. Such technology can achieve an up to 80% decrease in volume reduction when all fluids have evaporated, and the system capacity ranges from 10 kg to 500 kg per hour. Integrated steam based treatment system, and this system combines internal shredding, steam treatment, mixing and drying in the continuous unit. Since most autoclaves and the hybrid autoclaves operate in the batch process, these technologies are sometimes referred as the advanced steam treatment technologies treating waste in continuous process. Chemical treatment. Chemical disinfectants, alkali hydrolysis, chemical decomposition are the chemical treatment method. Burial based disposal method, and it includes the encapsulation and inertization, sanitary landfills. Encapsulation and inertization. Encapsulation involves the filling of container with waste, adding an immobilization material and sealing the container. The process use either cubic box made of high density polythene or metallic drum. When containers are 3/4 filled with sharp pharmaceuticals and chemical wastage, and immobilizing agents such as plastic foam, bituminous sand, cement mortar or clay is poured into it, the material dries and the container is sealed and disposed safely. Inertization. In this technique, healthcare waste is mixed with the cement and other substances in a composition of 65% waste, 15% lime, 15% cement and 5% water. The formed mixture is allowed to set into cubes or the pellets and then is transported to a suitable storage site. Sanitary landfill. Sanitary landfills are the engineered method designed and constructed to keep the waste isolated from the environment, and there should not be any contamination of the soil surface and the groundwater. Burial. Hazardous waste can be buried in the special pit. For this purpose, the pit should be 2 to 5 meter deep and 1 to 2 meter wide. The bottom of the pit should be at least 2 meter above the water table. After each waste loaded, it should be covered with a 10 to 30 centimeter thick soil layer. If coverage with soil is not possible, lime may be deposited over the waste. When the level of waste reaches up to the 30 to 50 centimeter to the surface of ground, the pit need to be filled with dirt, sealed with concrete, and new pit should be dug if necessary. Septic or the concrete valve. This method can be used for the disposal of used sharp and syringes. In this method, a concrete pit of slab of 1 meter into 1 meter into 1.8 meter depth is constructed to accommodate SARP and syringes for certain period without contaminating the groundwater level. And we should install a safety fence around the site as well. This topic includes the selection of waste treatment and methods. This table shows the what technologies should be used to treat such wastes. Infectious wastes can be treated with autoclave, microwave, chemical treatments, sanitary landfills after encapsulation, burial after encapsulation, septic or the concrete wall after encapsulation. Similarly, sharp waste can be autoclaved or microwaved and can be treated with chemical encapsulation and inertization, sanitary landfills after sterilization, and after encapsulation, burial after sterilization, septic or concrete wall. Pathological waste can be treated with biological procedures like vermicomposting, composting, or anaerobic decompositions. Burial. Chemical waste can be treated with chemicals to maintain the pH. If it is acidic, it must be neutralized before disposing in the sewages. If it is toxic nature, its toxic nature should be um, discarded or neutralized. It can be placed in the sanitary landfill after encapsulation. Pharmaceutical waste, it can be encapsulated and inertization. Sanitary landfill after encapsulation. Cytotoxic waste can be chemically treated or encapsulation and inertization, or sanitary landfill after encapsulation. Now, in laboratory treatment of the chemical waste, as we are using the automated laboratory machines, and there is the more requirement of the wash solutions to maintain the machines, and there is a generation of lot of chemical waste while uh, running the machines and performing the test. So in the different areas, or if we have to say in the context of Nepal, people directly uh, discharge those wastage into the Suez without any treatment, and this is actually wrong practice that most of the lab are doing. uh, and also people uh, directly discharge the urine into the Suez, but we should first segregate it, either it is infectious or not, or it can cause potential hazard or not. Then we should discharge it in the Suez, or if it is infectious, we must uh, mm, we must treat it to prevent infectious spread. Let's get deeper into it. There are the different treatments of the chemical waste. First of all, we have to segregate non-hazardous from the non-regulated waste. When safer and allowed by the regulation, disposal of the non-hazardous waste the normal threats or the SWARE can be substantially reduced disposal cost. Such wastes are not regulated as hazardous, includes certain salts such as potassium chloride and sodium carbonate, many natural products, example sugar and amino acids, inert material used in the laboratory, so example non-contaminated chromatography resins and gels. These material can be decomposed off safely and legally in the normal trash or the down the drain. This type of waste is not regulated because it does not exhibit any of the hazardous uh, characteristic, ignitability, corrosivity, reactivity or the toxicity. Implement chemical waste treatment in your lab. Concern about the environmental impact, bans on the landfill disposal of hazardous waste and limited access to sewer disposal have encouraged the development of laboratory hazardous waste reduction strategy. The small scale treatment and the deactivation of the products and byproducts as part of the experiment plan is one approach that can be used by the researchers to address these problems at the laboratory level. With the exception of neutralization, these processes are intended for the treatment of small quantities, not more than a few hundred grams or the milliliters. Larger quantities should be treated only in the small batches. Metal azides destroyed by the reaction with nitrous acid, acid base. Collect them separately and neutralize one with the other. If the acid or the base is highly concentrated, first dilute it to the concentration below 10%, mix the acid and base to the neutralize and dispose in the drainage with plenty of water. Toxin products such as one containing heavy metals and the toxin ions such as cyanide and sulfide should be disposed of according to the approved protocols. And for the cyanide we have to do alkaline chlorination, then we can discharge the waste in the sewage. And for the sulfide we can do pit burial or cultivation and surface disposal. Another waste is soil halides and anhydrides. As these waste can readily react with the water, alcohols and amines, this should never be allowed it to come into contact with water that contains such substances. Most compounds in this class can be hydrolyzed to water soluble products of low toxicity. Next, aldehydes. Many aldehydes are the respiratory irritants and some formaldehyde, acrolein are quite toxic. Some can easily be oxidized to corresponding carboxylic acids which are usually less toxic and less volatile. Hydrogen peroxide can be used for some oxidations. And next, alkali metals. Alkali metal has the properties to react violently with water, common hydroxylic solvents and the halogenated hydrocarbons. Such metals can be destroyed by the controlled reaction with an alcohol, and the final aqueous alcoholic material can usually be disposed of in the sanitary sewage. Next waste type is amines. Aspired potassium permanganate efficiently degrades aromatic amines. The mixture is then flushed down the drain. Inorganic cyanides. Inorganic cyanides can be oxidized to cyanate using aqueous sodium hypochlorite, bleach. Hydrogen cyanides can be converted to sodium cyanide by neutralizing with aqueous sodium hydroxide and then oxidized. Thiols and sulfide destroyed by oxidation to a sulfonic acid with sodium hypochlorite bleach. New waste treatment technologies. There are the certain new treatment technologies that are plasma pyrolysis, superheated steam, ozonization, promissions. Plasma pyrolysis. Plasma pyrolysis involves plasma or torch or electrodes which use ionized gas in the plasma state to convert electrical energy to super high temperature up to the several thousand degrees Celsius. Superheated steam. This technology uses superheated steam at 500 degrees Celsius to pulverize infectious, hazardous chemical or the pharmaceutical wastage. These steams are further heated up to temperature of 1500 degrees Celsius. Ozonization. Ozone gas can be used as a disinfecting agent for wastage. Ozone can break down to more stable forms such as oxygen easily. The waste are shredded and exposed to the agents. Promissions. Promissions combines a mechanical process with the removal of heat to destroy pathological waste. It uses liquid nitrogen and mechanical vibration to disintegrate the pathological waste into a powder before burial. Uh, this chart shows the waste treatment. First of all, we can go for segregation. All waste that are generated are assumed to be potentially infected, and it can be segregated into general non-biodegradable waste, general biodegradable waste, pathological waste, SAP, infectious waste, and used personal protective equipment waste. General non-biodegradable waste can be further classified into general non-biodegradable waste and general biodegradable waste. Treatment and disposals are the autoclave, microwave, dispose in the burial pits and the lime cover up, stored in the secure place for minimum 7 days and dispose in the municipal landfill or the incineration. And these are, you can go through these all. Uh, there are the different waste management policies or the in the different healthcare facilities. Among them, I'm going to talk about the healthcare waste management at the clinical or the pathology lab clinic. Non-risk healthcare waste, biodegradable that can be compostable. Such waste can be composted to produce compost manure and can also be used for the production of biogas, and the responsibility is taken by the chief of the clinic and the authorized person. Recyclable, non-biodegradable waste. Recyclable items should be recycled and reused. Responsibility is handled to the chief of clinic and the authorized person. Other non-risk waste. If the waste cannot be composted or recycled, contact the local authority for disposal. Again, the responsibility is handed to the chief of the clinic and the authorized person. Healthcare waste requiring special attention, such as human anatomical wastes such as placenta, human tissues. Such wastes should be disposed in the placenta pit. Safe burial controlled incineration as per SOP. Again, the responsibility is handed to the chief of the clinic and the authorized person. Sharp such as injection and the blades, mutilated cut the tip of the syringe and the needle with needle and the hop cutter, then autoclave and dispose properly, or we can disinfect with the 0.5% chlorine solution and dispose safely. Pharmaceutical waste such as waste comprising of the dead, expired, contaminated and discarded medicines. We can manage such wastage by applying return back policy, return the waste to the store and from the store to the supplier, or dispose in the secured landfill with encapsulation. Cytotoxic pharmaceutical waste such as post expiration date cytotoxic pharmaceutical disintegrable liquid residues of cytotoxic concentrates, and such wastes can be managed by applying return back policy, return the waste to the store and from the store to the supplier or sanitary landfill with encapsulation, and responsibility are handed to the chief of the clinic and the authorized person. Now the infectious and the highly infectious wastes. Uh, it it can be categorized into the infectious waste such as blood bags, gloves, and syringes. It can be managed by autoclaving the waste and disposed properly, multilate or cut before disposal, or multilate or cut gloves, syringes, bloods, bags and disinfect with 0.5% chlorine solution and dispose safely. Responsibility is handed to the chief of the clinic staff. Wastage such as bandages and the cordons, which are infectious, can be managed by autoclaving the waste and then disposing properly, or disinfect waste with 0.5% chlorine solution and dispose safely. Again, the responsibility is handed to the chief of the clinic staff. Now the radioactive waste such as cell radiation courses, liquid and the gaseous material contaminated with radionuclide, paper cups, straws, needles, syringes, test tubes contaminated with the radionuclides, and such wastes can be managed by applying return back policy. Return the waste to the store and inform the store to the supplier. It should be agreed at the purchasing phase. Or radioactive isotopes should be collected, packaged, inventoried and secured for stored for the time period suitable for complete radioactive decay. In the case of the mixed radioactive and the infectious wastage, the radioactive component is addressed first and later suitable treatment for the infectious components should be carried out. Again, this responsibility is handed to the chief of the clinic concerned staff. Other hazardous waste such as heavy metals and the mercury, chemical waste should be collected and stored separately in the glass bottles with water and well labeled and stored in the secure place. Chemical waste should be chemically treated and discharged into drain after massive dilution with the plain water. Now, came to the end of our today event. Thanks to everyone and apply to your work site for the good infection prevention practice. Thanks for again.